Imagine the CPU as the brain of your computer. Now, just like our brain uses short-term memory to quickly recall and process things, the CPU uses registers. They are small, super fast storage kind of areas inside the processor that keeps things moving. In this small session, we'll be talking about, or we are going to have a kind of walkthrough of the registers in the Intel architecture 32-bit. Think of this as exploring the toolkit of the CPU. Each register is like a special tool with a specific job. First, let's meet the general purpose registers. IA32 has 8 of them. I will like to call these as CPU's scratch pads, places where it jots things down while working. Like say EX, the CPU's favorite scratch pad for mathematics, operations, IO, and even saving the results. EBX, oftenly used as a base pointer to reach to memory. ECX, the built-in counter, it's great for loops and repeating tasks. EDX, it works as an extra storage when numbers get too big, especially when multiplication or division is operated. What's cool is that these registers aren't fixed in size. They are 32-bit, but you can also use them just 16 bits, say AX, BX, CX, DX, or even 8 bits like AH, AL, BH, BH, CH, CL, DH, DL. It's like having one notebook where you can use the full page or just tear up small section depending on your need. Now let's talk about segment registers. Intel architecture 32-bit has 6 of them. To make this simple, think of memory as a big apartment building. Each segment register is a door label telling the CPU which room to enter. For example, CS, called as code segment, points to the room with the program instructions. DS, that is data segment, the room where all variables live. Stack segment, SS, keeps track of the stack, the place where the temporary storage during the function calls is given. Then ES, FH, GS are the extra doors, usually for special stuff like video memory or operating system data. So segmentation is basically dividing memory into rooms with different purposes. So the CPU never gets lost moving around. Then comes index registers. When I said 8 general purpose registers, among these 5 listed here, 4 of them are part of that general purpose registers. Like these are the CPU special guides. They help managing memory, stack, and the program flow. Like say ESI, the source index, points to the starting place when copying data or handling strings. EDI, destination index, points to where the data should go. Together, this ESI and EDI are like a delivery team. One picks up, another drops it. These two are part of that general purpose registers. ESI and EDI are among the 8. Then EBP, the base pointer, marks the base of the current stack frame, helping accessing function inputs and local variables. Stack pointer, ESP, always points to the top of the stack. When you push something, it moves down. When you pop, and it moves up. EBP and ESP also are part of general purpose registers. And then comes one important register called EIP, instruction pointer, also known as program counter. This is one which is very, very special. It is like the CPU's GPS. It always knows the address of the next instruction to execute. So These registers are basically the CPU's road signs and guides, making sure that data and instructions never lose their way. Finally, we have the E flag register. Think of it as CPU's dashboard with a little indicator lights. Each light tells you something about the last operation. For example, carry flag CF is used or it is on if a math operation overflows. Zero flag ZF, it is on if the result is zero. Sign flag SF, it is on if the result is negative. IF interrupt flag lets the CPU allow or block interruptions. DF direction flag decides whether the strings are processed towards in the forward direction or backward direction. OF overflow flag, it is on when signed numbers go out of the range. Parity flag PF, it is on if the result has even number of ones. Why does this matter? Because it lets the CPU to make the decisions. For example, if the result is zero, go here. If not, go there. This kind of control or this kind of decision can be made by CPU very easily by making use of these flag registers. And one can say that this is the backbone of conditional branching in programming or assembly programming basically. So if we put it all together, general purpose registers are scratch pads. Segment registers divide memory into rooms. Index and pointer registers are the guides and GPS. And the E flag register is the dashboard that tells the CPU how things are going on. All of them working together is what keeps your program running smoothly and efficiently. Without these registers, the CPU would like a person trying to solve a math problem without pen, paper, or directions. It would be lost.